Okay, the next thing we're going to look at is graphing the derived function. So that means instead of drawing a function that's x coordinates versus y coordinates, it's now going to be looking at a function which is x coordinates versus the gradient, which can be written as dy by dx, or if in function notation, f dash dx. Okay, quick point to note that if we've got a quadratic term, for example, a parabola, we know that if we differentiate a quadratic term, then we'll get a linear term, so that the derivative of a parabola is a straight line. Okay, so x squared is a quadratic term. X squared we know is parabolic and it's concave down. Well, if we were to differentiate x squared, we'd get 2x. We know that 2x is linear because it's of the form y equals mx plus c. So the derivative of a parabola is a straight line. Okay, let's get into some of these questions. First one we're going to have a go at is to graph the derivative of the following function. Okay, so we've got a stationary point when x equals 1, and we've got a stationary point when x is 3 at 3, 6. So it's a min at 1, 0 and a max at 3, 6. So we want to draw what the gradient of this function will look like. The best way to think about this is we need to analyse x coordinates at stationary points, before stationary points, between stationary points and after stationary points. And what we're doing is analysing the gradient of the function. So let's just go through a few of these. The first thing that we do is draw a table out. Okay, now when the x coordinate is 1, we know that we've got 0 gradient, and when the x coordinate is 3, we can see that we've also got 0 gradient. So we're going to look at the behaviour of the curve, i.e. its gradient, before we get to 1, which is here, between 1 and 3, and after 3. So in short, we're going to look before stationary points, at stationary points, between stationary points, and after stationary points. So the first stationary point occurs at x equals 1, so we're going to look before we get to 1. We're then going to look at 1, which is here. We're then going to look between 1 and 3. And then we're going to look at stationary points again, that's at x equals 3. And then finally we're going to look after stationary points, that's after 3. So before stationary points, at stationary points, between stationary points, and after stationary points. Now we can see clearly that before we get to an x coordinate of 1, the gradient of the curve is negative. Now how do we know? Because it's sloping down. So I can't say with any certainty the exact value of the gradient, but what I know is that it's certainly negative. I then know that the gradient of the curve at 1, well, it's a stationary point, which means it's a position of 0 gradient. Between 1 and 3, the curve is going up, so it's got positive gradient. At 3, it's going along again, so it's got 0 gradient. And then finally, after 3, the curve is going down, so it's got negative gradient. Okay, we're now going to put this into a sketch. Okay, we're now graphing the derivative given by dy by dx. Okay, now the first point order is to put down positions of 0 gradient. Okay, so this is now a number line for gradient. So anything up here is positive gradient, anything down here is negative gradient, and anything on the x-axis is 0 gradient. So think about it as if this was a thermometer. That would be above 0 up here, below 0 down here, but 0 here. Okay. So 0 gradient first occurs when x equals 1. So let's put that in. Then 0 gradient occurs again when x equals 3. So the gradient then when x equals 1 and 3 would be 0. So it's not positive, which would be up here, or negative down here is 0. Okay. Now before I get to 1, what I know is that the gradient is negative. So before I get to an x coordinate of 1, the gradient is negative. Now that means that I would have to be below the x-axis, maybe somewhere around about here. Between 1 and 3, I know that the gradient is positive, so that would need to be above the x-axis, somewhere here. And after 3, I know that the gradient is negative back down here. Now, in terms of here, here, and here, I don't know the exact values, just that we're negative, positive, and negative. But I know that when x equals 1 and x equals 3, I've got 0 gradient exactly. Therefore, what I do is use these bits here then just as a guide, but I must go through here and here. So keeping the thing with a kind of nice continuous U shape, and that's what the curve would look like. Okay, next one, I'm going to draw the derivative of the function given by f of x versus x, and it's going to be a parabola this time that goes through -1 and 3, and I've got a stationary point at 1, 8, which is a max. Okay, now this is parabolic, which means it is a quadratic, which means when I draw the gradient will need to be a straight line, it will need to be linear, and that can be easily deduced from a quadratic term. If you differentiate a quadratic term, you will get a linear term. Okay, so I know that the graph of the derivative must be a straight line. So we're going to look before, at, and after stationary points. So the first stationary point occurs when x equals 1. So we're going to look before that and after that. These points here are just distractors. In terms of a gradient shift, there's not a lot happening here. So what I need to do again, I need to look before, between, at and after stationary points. Well, there's only one stationary point, so it's before, at and after. So let's set up a table. X versus gradient. So the first stationary point and the only stationary point this time occurs at x equals 1. So I'm going to look before 1, at 1, and after 1. Now you can see clearly before we get to 1, the gradient of the curve is positive. At 1, the gradient of the curve is 0, and after 1, the gradient of the curve is negative. Okay, we can now set that up with the graph of the derivative. Okay, so we know that we've got gradient which is 0, so we'll be on the x-axis when x equals 1. We know that the gradient before we get to 1 is positive, so before 1 I would need to be above the x-axis, and after 1 below the x-axis because the gradient is negative. It needs to be a straight line because when you find the derivative of a parabola, it will be linear, and there we go. Okay, let's try another. We're going to find the derivative and draw it of this one. Okay, so we've got minimum turning points at x equals -1 and 1, and we've got a maximum turning point on the y-axis when the y-coordinate is 1. Okay, so that is actually the point 0, 1. Okay, so remember that we look at the gradient of the curve before stationary points, at stationary points, after stationary points, and between stationary points. So the first stationary point we can see occurs at -1. So we're going to look before that to get going. So before -1. We're then going to look at -1. We're then going to look between stationary points, that's between -1 and 0. We're then going to look at stationary points, that's at 0. Then between stationary points again, between 0 and 1. And then at stationary points, at 1. And finally, after 1. Okay, we can see clearly that the gradient of the curve before I get to -1 is definitely negative. So the gradient is negative. At -1, we can see that the gradient is going along, so it's 0. Between -1 and 0, I'm going up, that's positive. At 0, the gradient is 0. Between 0 and 1, the gradient is the curve's going down, the gradient is negative. At 1, the gradient is 0, and after 1, the curve's going up, the gradient is positive. So we can now sketch that out. So remember that this vertical line now is a measurement of gradient. It's positive gradient up here, negative gradient down here, and 0 gradient here. Okay, so 0 gradient first occurs at x equals -1. It then occurs again at x equals 0. And it finally occurs again at x equals 1. Okay, before I get to -1, I know that the gradient is negative, so that would need to be below the x-axis before -1. Between -1 and 0, the gradient is positive, so between here and here, the gradient is positive. It would need to go up there somewhere. Between 0 and 1, the gradient is negative, and after 1, the gradient is positive. Remember that these are only guides, but I must go through here, here, and here. So that's just a guide, as is that, and that. Okay, and make sure it's got a nice continuous U shape, using these blobs here as a guide, and that would be the curve. Okay, let's try one more. We're going to sketch the derivative of this one. So we're told that the curve cuts through at -2 and 2 on the x-axis. We've got a turning point here of 1, 9, another turning point here of -1, 9, and another turning point 8 on the y-axis, so that would be the point 0, 8. So our turning points are here, here, and here. We're looking to look before, between, at, and after stationary points. These two are a distractor, there's nothing much happening there. Okay. So it's x versus the gradient. So the first stationary point occurs at -1, so we're going to look before -1, at -1, between -1 and 0, at 0, between 0 and 1, at 1, and after 1. So we can see that the gradient before we get to -1 is positive, the gradient at -1 is 0, the gradient between -1 and 0 is negative, at 0 it's 0, between 0 and 1 it's positive, at 1 it's 0, and after 1 it is negative. Okay, so let's draw the gradient then. So 0 gradient occurs at -1, 0, and 1. I've then got positive gradient before I get to -1. I've got negative gradient between -1 and 0. I've got positive gradient between 0 and 1, and negative gradient after 1. And using those as a guide, a function would look something like that.